Okay, this is question 3 from the third test. So with this one, the thing you need to know is that the log is a function. You put a number in and it gets another number out. But the important thing about log graphs, all log graphs, which I think I've mentioned in other videos, is that when you draw the graph of it, this point here is 1. So that means when you log 1, the answer's 0. So that coordinate there is 1, 0. 1 for x, log x is equal to y. So 1 for x gives 0 for y. So that's what we've got happening here. This stuff in the bracket has to be worth 0. So to find out what makes, has to be worth 1, not 0. So to find out what makes the bracket worth 1, we need to solve this equation. Now to solve this equation, this is GCSE maths, you should be able to do this. You make the equation, which is a quadratic equation because it's an x squared, equals 0 first. So we move this one to the other side. That gives us x squared minus 4x plus 4 equals 0. And then we factorise this quadratic. That's 2 brackets. If you remember this, you'll be rusty, but if you remember that we look for 2 numbers that multiply to make positive 4 and add to make negative 4. So for this question, it's minus 2 and minus 2. We then say we've got 2 things multiplying to make 0, so one of the brackets is worth 0, or the other bracket's worth 0. But in this situation, they're both the same, because there's the same numbers in the bracket. So there's only one answer for this, which is that x is equal to 2. So that is D. What they'll have done is they'll have hoped or expected some of the people doing this to solve this quadratic and forget to move the 1 over, which factorises differently. You'd have a 5 and you'd have a minus 5 and a 1. Yeah, a 5 and a minus 1, so that's B and C. So lots of people will have gone for E, but that's wrong because they've forgotten to move the 1 over. And this is question 5 from test 3. This is a really difficult question. You would struggle to answer this. This is another one of those differentiation questions. I'm going to have to talk you through how to differentiate a new function. The thing to know, if you're going to remember this, is that if you do e to the natural log of anything at all here, we've obviously got something more complicated than just x, but the answer is just this x thing here. So if you have an e to the ln of something, it's equal to just the something. So where they've written f of x is equal to e to the ln of that square root, that's just the same as the square root of x cubed plus a cubed. Now a is a constant, so they're saying a is like 4. So this is just a number, okay? It's not a variable like the x is. So in order to differentiate this, the first thing we have to do is make the get rid of the square root, and we get rid of the square root by rewriting it as a power. Now again, if you remember from your GCSE maths, the square root of something is the same as x to the power of a half. So we're going to swap this root for a power of a half. We're then going to use the thing called the chain rule, which I talked about on the other videos for differentiation, which is when you pretend the thing in the bracket is just an x. You then bring the power down and take one off the power. So this is starting to differentiate it now. So the power comes to the front. We leave this as if it was just an x. The power turns into one less than that. So we take a whole one off this power, so that becomes minus a half. And then we multiply by the differentiation of what we pretended was an x. So we multiply by what we get when we differentiate this. Now when we differentiate this, because this is just a number, this will disappear, and this bit will bring the power to the front and take one off the power. So that will become 3x squared. So just looking at the answers, the only things we've got are things with a 3x squared, so that gives us A as an option. B is not an option. B is wrong because there's not going to be this e to the ln anywhere in the answer, so it's definitely not B. It's not C because there's no 3x squared. It could be D. So those are our only two options really. I'm guessing it's not E, it's not none of the above. But we're going to have to do a bit more work on this to get to the end. The next thing to remember is that, well, we can discount D actually, because this would not be square root, because that's a positive a half, and we've not got a positive a half in our answer. This would be written in power form, 3x squared x cubed plus a cubed to the positive a half divided by 2. This is where the divided by 2's come from, so it's almost right, but this power's wrong, so it's not D. The power is wrong because a minus power turns things into fractions. X to the minus 1 is the same as 1 over x. So what we've got here is we've got 1 over, because of the minus power, 1 over the square root of this. So that is A. I've got a 3x squared on the top. I've got a 2 on the bottom. And this negative power here makes it go underneath a fraction. And we've got the half as well, from the same as before. So that will be x cubed plus a cubed, but on the bottom of a fraction with the square root because of the half. So the rule I've used there to turn this into this 1 over the square root is I've said that, say, a to the minus a half is the same as 1 over the square root of a. That's the rule I've used to move this bit underneath the fraction line.